So now we have studied till now what exponent means. Now let's solve equations in which exponents are there. Now remember, whenever you are solving equations in which exponents are there are only two things that you must do. So what you have to do is that first you have to ensure that first either the base is same or the power is same. If the base is same, our case 1, then a raised to the power b equals to a raised to the power c. Now here you can see that if you have simplified an equation up to this level, what you have done is that the bases are same, then it has to be, then the powers, the exponents on the both sides too should be same. So then b must be equals to c. In case 2, what is that the powers were same, the bases were not. So in this case, let's suppose you could simplify the equation to the level that a raised to the power x equals to b raised to the power x. So when you have reached to that stage, you have ensured that the powers, the exponent are same. So then the bases too should be same. So now you can write that a equals to b. So these are only two ways how you can solve equations that have exponents in them. You have to either ensure that both the left hand side and the right hand side of the equation has same base. If that is the case, then you will say now these exponents too should be same. Or you have to arrange the LHS side and RHS side of the equation in such a way that their powers are same. As long as the powers are same, then you will say now in order to this equation to be true, the bases too should be same. So now let's solve some problems. This one is an easy problem, that x squared dot x raised to the power m equals to x raised to the power 9. When we are going to solve this problem, we see that it is an equation in which our terms are written in exponent form. So what we are going to do is we are going to ensure either the bases are same or the powers are same on left hand side and right hand side. Now here you can see that the x is a common thing in both the two sides of the equation. So what I'll ensure is that the bases are same. Now on the left hand side, I can further simplify it as and write it as x raised to the power 2 plus m equals to x raised to the power 9. Now what I have done is that I have solved this equation. I've kind of solved this equation. How? Because I have just ensured that the bases are same. Now bases are same, then exponents too should be same. So the exponents too should be same, and now I can say that then exponents are same, then 2 plus m equals to 9, or then m is nothing but 7. So that's how you can solve equation in which exponents are there. Let's solve another equation. So another equation is that x raised to the power minus 4 equals to 625, and now what is the value of x? Now again, you have to see that in the right hand side terms, 625 is not in the exponent form. So first what I'm going to do is I'm going to write it in exponent form. Now I know that 625 can be written as 5 raised to the power 4. So now I can write this equation as x raised to the power minus 4 equals to 5 raised to the power 4. Now here you see neither the bases are same nor the powers are same. I'll have to do something extra so that I can ensure either the base is same or the power is same. So I can write this 5 raised to the power 4 as 5 raised to the power minus 1, and then whole of this raised to the power minus 4. So once I can do that, I can write this equation as x raised to the power minus 4 equals to 5 raised to the power minus 1 and whole of it raised to the power minus 4. Now what I have done again in the LHS side, in the left hand side and in the right hand side, my powers are same, my exponents are same. If exponents are same, then my bases too must be same. Now so then x equals to 5 raised to the power minus 1. 5 raised to the power minus 1 is nothing but 1 upon 5. So that's how you can solve equations in which exponents are there. Let's solve another problem. It states that if m minus 2n equals to 5, what is the value of 4 raised to the power m upon 16 raised to the power n? Now different options can be given to you, that which of the following options is equivalent of 4 raised to the power m divided by 16 raised to the power n. So how do we solve these kind of problems? So first what I'm going to do is that I am kind of simplifying my given expression, that was 4 raised to the power m divided by 16 raised to the power n. I can write it as 4 raised to the power m divided by 4 square and all of this and then raised to the power n, because 16 is nothing but 4 square. So now then I can write it as 4 raised to the power m. In the denominator it is 4 raised to the power 2n. Now this 4 raised to the power 2n, which is in denominator, I can take it to the numerator. When I take it to the numerator, I can write this all of the expression as 4 raised to the power m minus 2n. Now again, this 4 number, I can write it as 2 raised to the power 2. So then I can write it as 2 raised to the power 2, which then in power is also m minus 2n. So then I can write it as 2 raised to the power 2.5, because I have been given already in the problem that m minus 2n equals to 5. So then m minus 2n equals to 5. What I have is 2 raised to the power 2.5 equals to 2 raised to the power 10. So that's how we can solve. Now let's simplify this term. This is a big term of 2 raised to the power x's, many 2 raised to the power x's, and let's simplify this term. So what we do? First, in the first parenthesis, you see that there are how many 2 raised to the power x's? There are total 4, so I can write it as this first parenthesis as 4.2 raised to the power x. Similarly, second parenthesis, I can write it as 2 multiplied by 2 raised to the power x. Now 4 is also 2 raised to the power 2, so I can write it as 2 raised to the power 2 dot 2 raised to the power x. Then in the second parenthesis, 2 raised to the power 1 dot 2 raised to the power x. 2 and 2 raised to the power 1 is one and the same thing. Now I can see in this all these 4 2's, I have bases is the same. The powers are different, so now I can apply my exponent formula for all these four different terms. So now I can employ my formula of exponent for all these 4 terms, and I write it out like 2 raised to the power 2 plus x plus 1 plus x, which then I can simplify and write it as 2 raised to the power 2x plus 3. So that's how you can solve these problems of exponents. So that's all about this chapter of exponents. So now what we learned in this chapter of exponents is that there are big numbers, these big numbers, even small numbers can be written in exponent form. In exponent form, there's always a base and then there is always a power. If it is written such as x raised to the power m, then it means that x is going to multiply to itself 5 times. Now the second thing that we must learn is the different formulas of exponent. Unless and otherwise you don't learn these formulas of exponent, you cannot solve the problems on exponent. Now the third thing that we learn is about how to solve equations in which exponents are there. That while solving, we ensured that right hand side equals to right hand side can only be there when both the bases and exponents of left hand side equals to bases and exponents of the right hand side. So we have to have 2 cases. In the first case, our bases would be same, the powers would be different. So we will say then in order that LHS equals to right hand side, our powers too should be same. While in the second case, what will be that our bases won't be same, but the powers will be same. Then again, we will say that in order that both LHS be equals to RHS, the bases too should be same. So that's all about exponent chapter. Thank you.